Hi, hey guys. It's Tuesday, March 24th. We are starting a new unit. Y'all did a very good job on yesterday's test. Thank you for almost everybody submitting a test. We only had one person not submit something, so that was greatly appreciated. I hope you guys found it easy to communicate back and forth with me. I certainly enjoyed it. Hoping you got something out of that. So today, doing something a little bit new. I'm going to use a document camera instead of the smart program because I need to actually show you. So I'm going to write out what it is that you're going to be doing. It's going to be it'll be a little bit easier for me than trying to write on the smart screen, which has been a bit of a challenge. So here we go. So today we're doing trigonometric identities. Okay, and so what you might want to do is print this off on from the blog. I did put this on the blog so that it is printable. It's going to be tough for you guys to see this if you don't have it in front of you and use them. Typically, actually, if you want to print this off and cut it out, put it in your notebook. That's probably the best thing you can do. As you can see down here at the bottom, we will have a couple of others that we will get to, but we're going to spend a couple of days, maybe a day and a half or so, just concentrating on these top three: the reciprocal identities, the quotient identities, and the Pythagorean identities. So if you'll let me talk about those for a minute. I'll probably end up, because of the size of this video, I will probably end up doing 2 different videos today. So let me squeeze in here a little bit. Talk about the reciprocal identities. Now the reciprocal identities are something you should be somewhat familiar with, as we did all these, we've done these when we were doing basic trigonometry. So the sine of theta is 1 over the cosecant. In other words, we asked you, hey, how do you get the cosecant? And you would say, well, you reciprocate sine. And so that's what these identities are. It's just having them written down now on paper. So cosecant is 1 over sine, cotangent is 1 over cotangent, tangent is 1 over cotangent, so on and so forth. So that's those 6 identities. And yes, if we were in the classroom, you would have to memorize these. So do your best to just try to remember them. I'll probably refer to them pretty quickly as we move along. The next set here in the middle is the quotient identities. And if you remember from the unit circle that the y value, you can't see that. Try that again. The y value was the sine and the x value was the cosine. And so we would ask, well, how do you get tangent? And you guys would say it's the y over the x. Well, that's what we're doing. We're doing the y value over the x value. So that's sine over cosine. And then the reciprocal of that, how do you get cotangent? Well, it was the x value over the y value. So all this, once again, from the unit circle. Stuff up top was from the unit circle. Stuff down here is from the unit circle. And then these are going to be the newest ones. If you remember Pythagorean identity, sorry, you can't see that. Pythagorean theorem, a squared plus b squared equals c squared. Well, these are known as the Pythagorean identities. Most popular is this one right here. The sine squared theta plus cosine squared theta equals 1. But these are very identifiable. These Pythagorean identities are very identifiable by their square. Do I have a... Yeah, let's see. By their square. Okay, most of the time, if you see a square along with a plus sign, then you're having to use a Pythagorean identity within that problem. And we'll also use Pythagorean identities when you want to use right triangle trigonometry. So as we progress, we get into the problems that we're going to work on today, Even part of the directions tells you not to use right triangle trigonometry, but instead to use Pythagorean identities. Okay, so these are the three sets of identities that we're going to focus on today. Okay, so as we move forward, I would highly suggest that you print these off and put them in your notebook. Have them next to your work, nearby, so that you guys can refer to them quickly. Because I'm going to refer to them quickly. Okay, so maybe pause, print this out, and then come back to the video. I'm going to continue on. Okay. So first thing we're doing is we're using, once again, like I said, we're using trig identities to find the values. Do not use right triangles to do this. Don't use SOHCAHTOA. Okay? We're going to use the Pythagorean identities, the quotient identities, the reciprocal identities. We'll use these to solve these problems. That's where I keep saying you probably should have this printed out and nearby somewhere. All right. So, question is, how do we relate secant and tangent? What identity has secant and tangent in it? Okay, so once again, bring these back into play. When you look at your reciprocal identities, start off at the top with the reciprocal identities, right up here. Zoom in on that for you. Do any of these have secant and tangent together on the same equation? The answer is no. So we slide down, look at your quotient identities. Do any of these, and there's only two of them, do either of these have secant and tangent in the same equation? No. Just keep sliding. Keep on going. Go down to your Pythagorean identities. Right here in the middle. Right there. You have secant and you have tangent in the same equation. So that is our identity that we want to use for this problem. So, secant squared theta equals tangent squared theta plus 1. So we get to plug and chug and solve an equation. So, our secant squared is 3. So the 3 is going to come down here. So that's going to be 3 squared. That's going to equal tangent squared theta plus 1. And from this point, it's just solving an equation. Hardest part's going to be figuring out what identity to use. Okay, and so from here, we just have at it. So this will be 9 equals tangent squared plus 1. Subtract the 1. 8 equals tangent squared theta squared. Square root both sides. When you take the square root, plus and minus, 2 square root of 2, no decimals, equals tangent, and there it is. That is tangent. And that's how we use an identity to get a value. And most, they're all going to be relatable. We're not going to give you one that doesn't work. Okay? So be patient with that. Just got to find the one that matches the information given to you in the problem. So next problem. Scoot that up a little bit. Okay. Find the identity. Find the identity that matches cotangent and sine. Cotangent and sine. Not going to happen up here. Not going to happen here because you can't use cotangent and sine when you have a third trig function in play. So the sine and cotangent don't relate up top. You can't use this one because of the cosine. So we have to come down here to where cosecant and cotangent is, because everybody's supposed to know that cosecant comes from sine. Keep those identities close. Cosecant theta squared theta equals cotangent squared theta plus 1. Okay, 1/5 is the cotangent, so it's going to come down here. 1/5, it's going to be squared. No decimals in any of these answers, guys. Everything's going to be a radical and or a fraction or a whole number. And feel free to use a calculator to do the calculation. So I tell you what, we'll use calculator. If you can see that, we'll zoom in a little bit. So 25/5. 26/5. So that's a 6. That's a 6. Okay. So let's see. Cosecant theta squared, don't forget the squared, equals 26 over 25. Square root, cosecant theta equals plus minus. All right, can't take square root of 26. There's no number that divides into 26. It's a perfect square. So square root 26 over square root of 25 is 5. Now, might look like you're done, but don't forget what you're trying to find is sine. So how do you get sine from cosecant? We reciprocate. So let's see. Scoot this up just a little bit. Zoom it out. And sine of theta will equal 5 over square root of 26. Can't leave that as a radical on the bottom. So that will be 5 square root 26 over 26, and there it is. That is the sine. So I hope you know how to use your calculator, how to reciprocate, how to rationalize denominators. Okay, all that's going to be helpful. I don't have a graphing calculator at home, so I have to use the TI-36X Pro. All right, third problem. Then I'm going to end this video and start a new video on simplifying. Okay, third problem. How do you relate cosecant and cosine? Well, last two problems have both been Pythagorean identities. So what do you think chances are this one? Okay, once again, we're doing cosecant and cosine. So let's see. It's cosecant and cotangent. That's secant, which is cosine and tangent. That doesn't work. What about sine and cosine? Well, here's the cosine. And cosecant lies inside a sine, so there it is. We'll use this Pythagorean identity. Okay, that's the Pythagorean identity we'll use. The 2 goes down here, but becomes 1/2. Because you're not given sine, you're given cosecant, so you have to reciprocate it to get it to work. Plus cosine squared equals 1. Okay, 1/2 squared is 1/4. Scoot this up a little bit. Subtract the 1/4 from the 1. Okay, ready to square root. And cosine, which is what we're looking for. We are looking for cosine equals plus minus. What's the square root of 3? Can't do it. Square root of 3. What's the square root of 4? That's 2. And there it is. Alright, so that's going to be the end of this half of the lesson. I'm going to end this video and start a new lesson on simplifying. See you in a minute.